Okay, good evening, everyone. It is my pleasure to warmly welcome you all to today's session of the Research Methodology Lecture Series organized by the Journal of Marginalized Communities and Social Justice. This lecture series is designed to provide structured guidance uh, for students, early career researchers, and practitioners who aspire to produce high quality publishable. So today's session focuses on a very important aspect of research. Researchers collecting data in how effective. Today's session we will be covering mainly truly privileged to have with us Mr. Azurika Jayasuriya, lecturer from the Department of Decision Sciences at the University of Sri Jayawardhanapura, Sri Lanka. She is also an experienced data analyst, and we are confident that her expertise will greatly enrich our understanding of these techniques. On behalf of the organizing team, I extend a very warm welcome to you, Ms. Chaturika, and thank you for taking time to share your knowledge with us today. I would also like to welcome all participants who have joined with us. Your presence reflects your commitments to developing strong research skills, and we hope this session will be both informative and engaging. So without further ado, I invite Mr. Surya to begin today's session. Thank you.
Thank you, Diniti. So welcome you all back and good evening. So today I'm going to focus on analyzing data, and also I will be focusing on a very specific method technique that we can use in analyzing quantitative data, and also very popular among the researchers nowadays, quantitative researchers nowadays, which is PLS-SEM. So today I will be covering up these aspects. So I will be first explain the difference between PLS-SEM and CB-SEM, and also I will introduce the SEM first, and different how to do the measurement model analysis, and how to first I think this should be corrected. First we will discuss how to do a measurement model analysis, and then we will discuss interpretation of the findings, and then the higher order measurement model. So you will understand this after I discuss this, and then finally the structural model analysis. So at this time you will not be able to, I think, understand what is meant by measurement model and structural model. But when we do the discussion, you will realize about this. And before moving first into this SEM, let me introduce these different multivariate analytical techniques. So multivariate analytical techniques mainly we do in quantitative data analysis. So the data that we collect through questionnaires and different methods that we can analyze using different multivariate analysis. So first, let me show you what are the different kinds of techniques that we have to analyze the multivariate data. So first, if I explain you what is meant by multivariate, so if you are familiar with quantitative research, as I explained you the other day in data collection, if you are using a questionnaire to collect data for your research, there will be different variables that you will be collecting data on, right? So that is called multivariate. So you have multiple different kinds of variables that you will be using for your study, right? So to analyze these different kinds of data, quantitative data on multiple variables, we have different techniques. So first, there are two types, dependence and independence, right? So if it is dependence, that means we have a dependent variable in our model, and we can have one or multiple independents, right? And also we can have multiple dependents as well. So based on how many dependents you have, the type of analysis will be different, right? So here you have given a decision flow you can use in selecting the most suitable multivariate analytical technique you can use in your study, right? So first you can ask how many variables you have to predict in your model, right? So if you have multiple dependents in your model, in your research, and also if you have multiple independents in your research that you are going to analyze the relationship impact, so then you can go with this structural equation modeling, right? So that is the focus in today's session. And there are two types of ways we can do the structural equation modeling. One is CBSEM, the other one is PLS-SEM. So today's focus is PLS-SEM, and I will very briefly introduce you to the CBSEM as well. So don't worry about it. And if you have several dependents and in a single relationship, so it's something like let's say that you have that you are going to model equation. So there, if you have number of dependents in your equation, so then you can go to two options. You can look at two options. That is canonical correlation analysis, I'm sorry, and multivariate analysis of variance, right? So that you can do if your dependents are matrix. And if those are non-metric, and if you have metric and non-metric in mix, you can go for canonical and canonical analysis with dummy variables, right? And if you have a single dependent, and if you have a single independent, so then you will have a simple regression analysis. And if you have a single dependent and multiple independents, then you can go for multiple regression analysis, right? And also you can go for a conjoint analysis and logistic regression if your dependent variables are not non-metric, right? So don't worry about this. And also I am not an expert of all of these techniques. So this is based on the nature of your research question, right? So if you have your research questions and your variables non-metric and have mix in metric and non-metric, so then you can use these different kinds of techniques, right? So the today's focus actually is on this, the structural equation modeling. And also before going into the SEM in deep, we have analytical techniques that we can use when the multivariate is an independence, right? So it's something like there is no dependent variable in the model, right? So it's something like, let's say, factors. So let's say when you want to come up with a scale, when you are developing a scale by your own, a measurement scale or a questionnaire, then you can go for these kind of methods. So we have exploratory factor analysis and confirmatory factor analysis. We are using these in most of the analysis we do in quantitative techniques. And then we can go for cluster analysis and also multidimensional scalings, correspondence analysis. Likewise, if we have only a model, it's not actually a model, it's something like a scale if you are going to develop using a research, right? So if you are in your PhD, if you are in your PhD stage, if you are doing a quantitative analysis, and if you are developing your own questionnaire, you can go for these methods, exploratory and confirmatory factor analysis, right? So those are the main techniques we have in analyzing multivariates or multiple variables. So as I told you, the today's focus is this, because since when we are doing a very initial researchers, we tend to use a lot of regression analysis, right? So it can be simple or multiple, right? But we cannot derive much of information if you are using a simple regression analysis or multiple regression analysis, right? So using the similar kind of data, we can go for a bit of a depth analysis using structural equation modeling, right? So I will explain you what is actually structural equation modeling is. It's a very, very now popular analytical technique that we use in quantitative analysis, right? So in multivariate analysis, it involves the application of statistical method that simultaneously analyze multiple variables. So that's what I told you at the beginning. So multivariate analysis means we have multiple variables. We try to understand sometimes the relationship, sometimes not the relationship, but some kind of the factorial nature of the variables. And the variable typically represent measurements associated with individuals, companies, events, activities, situations, and so forth, right? So you can have multiple variables, or you can do multivariate analysis on individuals, on problem related to individuals, something like customer satisfaction, right? Employee satisfaction, customer retention, patronage, right? And also you can use the multivariate analysis to study company related problems, something like organizational performance, competitiveness, or competitive advantage, right? Or you can use the multivariate analysis to study events, something like let's say something like, let's say, a pandemic, right? Or a training program, right? So to measure the success of a training program, to measure the effect of a pandemic, right? Or an activity, right? Something like a sports, right? So to measure the success or impact or of a sports and situations, right? So situations or scenarios we can also analyze using multivariate analysis, right? So situation can be in many form. So it can be a phenomena or it can be just scenario, right? So the measurements are often obtained from surveys or observations that are used to collect primary data, but they may also be obtained from databases consisting of secondary data. So I think I explained you the other day what is the nature of primary data and secondary data. So we can perform multivariate analysis in the both kind of data, but those should be most of the time either categorical or should be numerical, right? So something like the weight, the height, or something like, let's say, the length kind of numerical data, or it can be just yes or no kind of categorical data, or male or female kind of categorical data. It should be in those forms, right? It can be primary or it can be secondary. It doesn't matter. So we can collect the data to be used in multivariate analysis using surveys or observations, or secondary data, that means using reports, right? So there are two kinds of main two kinds of multivariate analysis. There are confirmatory analysis, there are exploratory analysis. So this is not about confirmatory factor analysis or exploratory factor analysis. This is not the same thing, right? So that's for the those who know about the factor analysis. So we can do multivariate analysis as a confirmatory analysis. So that means we can test the hypothesis, right? To confirm whether what we hypothesize is what is happening in a in a problem, right? So that is called confirmatory analysis. So the regression analysis, the multivariate or simple regression analysis are confirmatory kind of analysis, right? Or you can do exploratory analysis, right? So that means you can have a kind of idea, but you are not knowledgeable enough to make a hypothesis, right? So that means you kind of explore what is happening in the problem, what is happening in what you are going to study, right? So that is called exploratory analysis. So when we search for latent patterns in the data, in case there is no or any little prior knowledge on how the variable are related, if you are doing an analysis to find relationships that are not already known, is called exploratory analysis, right? So actually the SEM that we are going to discuss, that we are going to learn, is actually can be used in both, as a confirmatory analysis or as an exploratory analysis, right? So let me introduce you this structural equation modeling. So may I know anyone anyone who is today participating have used SEM before? Or if you have the knowledge in using regression analysis, have used regression analysis before? Yes. And anyone have used SEM before? Structural equation modeling before? Okay, is it SEM or is it regression that you have used, that you guys have used? Have used both, very good. So we have a few who knows SEM. That's good. Regression before. Okay. Yes, many have used regression before and only one, okay, very few have used both before, right? Very good. And I have got a question asking, is it mandatory to perform confirmatory or exploratory analysis for new tool or questionnaire? Yes. So the thing is, it's like this. So you are using questionnaires that has been developed to measure measure variables, right? So some variables are there having dimensions, right? That means you are not directly measure the variable, but you have dimensions that that we use to measure the variable, and questions are there to measure the dimensions, right? So in that case, let's say that the questionnaire is a very new one, right? So that is being very recently developed. Let's say something about resilience, something about sustainability has been in the picture for so long, but let's say something like on resilience, right? So, and also something like, let's say on AI related, right? Which are very new, right? So then we can use a confirmatory analysis or confirmatory factor analysis on a questionnaire to see whether the dimensions that is being labeled on these questionnaires are the same, right? So we can confirm it, right? And confirm it, and then we can use it, right? And exploratory analysis, we actually need to use when we are developing a new questionnaire, right? So in develop, let's say you are the one who are developing your questionnaire for your study, right? So if you are in a PhD, if you are doing a PhD study, if you are a PhD candidate, then you will sometimes can do your own scale development, right? So in that case, we can use the both exploratory and confirmatory factor analysis. But if you are doing a quantitative analysis, let's say regression analysis or SEM, and you can perform the confirmatory factor analysis on your questionnaire, right? So sometimes you get the same factors or same dimensions as being stated before, or you will get the new dimensions, right? So if you get a new dimensions, then that means your measurement scale or your questionnaire might need to be developed or amended for your context, right? So we are not doing it in our study, but you need to get that idea, right? So to get those ideas, we need to perform the confirmatory and exploratory factor analysis, right? confirmatory factor analysis at least. I think you got the answer. Okay, right. So let me introduce this SEM to you, structural equation modeling, right? Since most of you know the regression analysis, where we try to find a relationship and also impact between variables, which looks like this, right? So in a regression analysis, you try to find a relationship between, let's say very simply, between two variables, right? So like this. So you have an independent, you have a dependent, right? So in a simple linear regression, you have a one independent, you have a one dependent, right? So you try to measure analyze the relationship between this independent and dependent, right? So this can be organizational practices, this can be organizational performance, right? So when we are doing regression analysis, so mainly we have a very few softwares that we are using, right? And also we are measuring the value of this variable like this, right? So let's say you have 5 questions to measure this variable. 1, 2, 3, 4, 5. Don't mind my sketching, okay? 1, 2, 3, 4, 5, right? So let's say you have 5 questions to measure this variable, right? So let's say the first respondent, and you have a 5 measurement scale, 5-point Likert measurement scale, right? So let's say you got 2 for the first question, 3 for the next question, and 2 again, 2 again, and 2 again, right? So likewise, you can get the responses for all the respondents like this, right? I mean, similar to this, right? So how you measure the value of this variable is, you get a mean for all of these respondents, right? You calculate the mean of this respondent for these responses of the respondent, and you calculate the mean for the second. So likewise, so using the mean, you calculate the value of this value for this variable, right? So if you have used a software called SPSS, JAMOV kind of softwares to test regression analysis and even Excel, you need to first calculate this mean, right? Or average of the responses for each respondent, right? And that's how you calculate the value for all the variables. If you have a multiple regression, so you will do this for all the variables, right? The problem is not each questions having the same weight or importance to the variable, right? So some questions should have a different weight or different importance, right? But we cannot grab it. We cannot use it when we are calculating a very simple mean or simple average, right? So as a solution, what we can do is, that's what we do in SEM. So let's say we have 2 variables, 2 independent variables, and we have a 1 dependent. If you don't understand anything, just let me know in the chat box, okay? And so if we are using SEM, what we do is, we have questions to measure each variable, right? So let's assume this is a unidimensional variable. That means there are no dimensions to measure this variable, only questions, right? So to measure this variable also, we have questions. Let's say 3 we have. And to measure the dependent variable, we have questions like this, right? So here in SEM, we are not going to measure the mean or calculate the mean of the responses for each questions. But we are going to perform a regression analysis from each question to each variable, right? So it's kind of a mini regression analysis. Okay. So we are doing regression analysis from each question to each variable, right? So like it looks like a regression analysis in here, a regression analysis in here, and a regression analysis in here, right? So that's what we do mainly in SEM, right? So we are not using the mean as a value of the variable. We are going to perform regression analysis on these variable, right? From questions to the variable. So in that case, we can identify the actual nature of these variables, actual nature of the behavior of these variables, right? And also, in a regression analysis, we will have only a one dependent, right? So we cannot have multiple dependents, but in SEM, we can have multiple dependents and multiple independents, right? So we can analyze the impact, the relationship between the actually impact coming from these two independent on this dependent, and also these two independent on this dependent, right? So we cannot do all of these in a simple or multiple regression analysis, but we can go for structural equation modeling to identify or analyze this kind of a model, right? When you are going to do a research, you might have realized that we cannot like have very simple or few variables to measure a one dependent, right? So when we want to fully understand or actually understand a high level of the problem, then we need to go for a very complex kind of analysis, right? So those are facilitated by this SEM, right? So that is a simple idea of SEM, right? So that means we can go from a regression. So if you are plan to use regression in your studies, then consider using SEM, right? So, so in SEM, we have I have prepared about 90 slides, but don't worry, I'm not going to read the slides to you. I try to make you understand the concept, okay? So I'm not going to read these slides to you. Right. So there are two ways we can do the structural equation modeling. One is covariance-based SEM, or we in short call as CBSEM, and also another way is we can do the PLS-SEM or PLS-SEM, which is partial least square SEM. So those are the two ways we can do the SEM, right? So covariance-based SEM means we will need to satisfy all the multivariate assumptions or assumptions in regression analysis to use the CBSEM, right? So you might wonder what are the assumptions to satisfy. So the main assumptions is the normality of the distribution and normality of the normal distribution of the residuals. So that is the main and very important assumption in analyzing the regression, right? So if there is normality only, we can go for a parametric analysis. So covariance-based SEM is a parametric SEM, right? But if there is no normality, right? Mainly if there is no normality, we can go for non-parametric test of SEM, which is PLS-SEM, right? So most of the time, if you have done this quantitative analysis that you have collected data using surveys, using questionnaires, you might have experienced non-normal distribution, which is obvious, right? Because not everything behave normally, right? And also when your data is limited to some number and which is not representing the entire population, that means if you have very limited data, which is something lesser than 100, 150, also you might face non-normal distributions, right? And also, when you increase the number of responses, there can be some kind of clusters or small sets inside your data, right? So because of that also, there can be non-normal distribution, right? So that means it's something like this. Let's say you want to measure the performance of organizations who have used, let's say AI, right? Who have used AI platforms or AI systems in their organization, right? So they are the nature of or the way the organizations use AI can be different from industry to industry, right? So when you collect the data from all the organizations, let's say all the manufacturing organizations, so the data might be different, the responses might be different because they are in the different industries, right? So because of that also there can be non-normal distribution, right? So since most of the time these researchers experience or having non-normal data, there should be a way to analyze it, right? So that is the PLS-SEM. So you cannot go for CB-SEM, you can go for PLS-SEM. So let's say you have all the assumptions are satisfied, the normality, the linearity is a must, regardless the CB or PLS. And also multicollinearity is not there, and also homozygosity is there, right? So if all the assumptions are satisfied, then you can go for CB-SEM, right? And also there are data requirement. So you are having your sample size, no, which you can decide based on the Morgan table or any other probabilistic way. So here, if you are to use SEM, especially CB-SEM, your data should be enough to perform your CB-SEM, right? So that means you need to at least have 5 times or 10 times of your questions. That means if you have, let's say, 50 questions, then you need to have 500 as your data, right? So those kind of very rigid requirements are there to perform the CB-SEM. But we cannot always satisfy those requirements. But still, if you want to use SEM, we can go for PLS-SEM, right? So PLS-SEM provides more flexibility and more freedom to perform the SEM, right? So covariance-based SEM, we can use mainly to confirm or reject theories. That means in confirmatory analysis. And in PLS-SEM or PLS path modeling, we can do the exploratory analysis as well, right? So that means, let's say you have a model that you are going to test using questionnaires that is not very thoroughly studied, or if your questionnaires are very new, which is kind of an exploratory study, you can go for PLS-SEM, right? So if you are using CB-SEM, the main software you will be using is AMOS, SPSS AMOS, right? So which is an add-in to SPSS. AMOS is an add-in to the SPSS, right? And also a very non-user friendly kind of a software, because if you mess up in drawing the model, there will be a lot of issues when doing the analysis, right? So if you have used the AMOS, then you might have experience also. So may I know again what kind of analysis you have done in your SEM? Is it CB using AMOS or is it PLS? So we had few who have done SEM. May I know using which software you have done SEM? Yes, may I know, using which software you have done SEM? Very good. So PLS-SEM means you have used Smart PLS. So we had few who have done SEM. I got a one as PLS-SEM. What about others? Is it PLS or CB? Okay, no responses. Yes, right. So when it comes to using PLS-SEM, so it has a lot of, as I told you, flexibility in doing that analysis than doing CBSEM. So I'm not saying the CBSEM is not good. If you can use it, it's good. But if you have problems in your data, something like not enough data and have normality issues, then you can go for PLS-SEM, right? So when to use PLS-SEM versus CBSEM, right? So one thing I need to tell you is, so there are resources. The main resources in PLS-SEM is from the ones who have invented this software we are using for PLS-SEM called Smart PLS, which is from authors or scholars called Heyer, Starsted, and Ringer, right? So those are the three main authors who have published resources that we can use for PLS-SEM, right? So they have their number of books and articles that you can use. If you want, I can share a complete drive with you that have all the resources that we are using for PLS-SEM. So there are in there we have the books and articles we normally refer for PLS-SEM analysis, right? So in their books they have mentioned the places that we can use PLS-SEM, right? So as I told you, one reason to go for PLS-SEM is the non-normality of your data, right? So you most of the time experience, right? And also, if you have no enough data, not no enough, but not enough to do CBSEM, that means 10 times of your questions. If you don't have such number of data, then also you can go for PLS-SEM, right? But the linearity should be there. Okay, so that's why it's very important. You need to do all the assumptions testing before doing any of this analysis, right? Which is, as I told you, normality, linearity, homozydicity, and also the multicollinearity kind of assumptions you need to do before doing this analysis, right? So using the result of those analysis, you can mention in your research, in your reports, that because of these reasons that you are going to use the PLS-SEM, right? So otherwise you need to go for CBSEM. And also PLS-SEM usage is now getting higher and higher in most of these management and marketing research, right? So that also can be used as a reason that you can give as a justification in using PLS-SEM, right? So here in the slides, all I have mentioned is given. As I told you, I'm not going to read the slides, but I'm going to explain this in short, right? So here also you have given the reasons to use the PLS-SEM, right? And also when your model is a very new one, very complex one, if you have number of dependents, right, that also can be used as an excuse or a justification to use PLS-SEM, right? So let's discuss how to do this PLS-SEM, right? So in structural model analysis, there are main two stages, right? That means we are doing the analysis in two phases, right? The first phase is the measurement model analysis, right? And the second phase is the structural model analysis. So let me explain you what is meant by the measurement model. Yes, I got a question. Okay. Let me explain you what is the measurement model and what is the structural model. You can always ask questions because this can be for some a new technique, right? So as I told you, this is how we are going to use the SEM when we have, let's say, mainly two variables. One is independent and one is dependent, right? So let's say we have a number of questions that we use to measure this variable. Let's say 4 questions, right? And also let's say we have 3 questions to measure the dependent variable, right? So as I told you, we in the sense the software itself run the regressions from these questions to the variable, right? And also for the dependent, for the both for the both variables, right? So, and also you will be in your study mainly, you will be focusing on this relationship between independent and dependent, right? So since we are running regression from questions to the variables, this is kind of a model, right? This looks like a mini model, right? And this also looks like a mini model, right? And we have a main model in here, right? Between these two, you are running a regression. So SEM also, the nature of the analysis is similar to the regression, okay? And you are going to mainly analyze the relationship between these two. But here also, we run regression between the questions and variables. So this is, as I told you, this is kind of a model. This is a mini model. This is also a mini model, right? So what we first do is we measure or assess these measurement models, right? So we have two measurement models, right? So the first phase of the SEM is assessing these measurement models, right? So when we are doing the measurement models, we are doing these together, right? And the second phase is the structural model assessment. That means we are going to assess the relationship between the main variables, right? So those are the two phases of the structural equation modeling. Okay. So in here, when we are assessing the measurement models, right? The measurement models of the independent and dependent variable, we need to understand the measurement scale, right? So measurement scale in the sense, it looks like this. It looks like this, right? Sometimes your variables, the questions in the variables have this kind of a relationship, right? So that means your questions reflect your variable, right? Sometimes your questions and variables, the measurement scale looks like this. Sometimes your questions form the variable, right? So that means it's something like this, right? So let's say something like logistic practices, right? So since I'm in the supply chain stream, let's say the independent variable is logistic practices, right? So then you will have questions like the delay in distributions, right? And errors in distributions, right? And also the distance traveled, right? And the cost of traveling, or the distribution, right? So likewise, those are the questions that we are using in measuring the logistic practices, right? So can we interchangeably use these questions? Or if we remove a one question, will there be an impact on the measurement scale of the logistic practices? No, right? So even using 4 questions, we can measure the logistic practices, right? Or we can go for six type of questions, right? So the idea is we can interchangeably use these questions, right? So even if you remove one question from the measurement scale, there will be no much of impact on the measuring that variable, right? But if let's say the independent variable is supply chain practices, right? Or inventory practices. Let's say supply chain practices. So what are the supply chain practices? Logistic, procurement, and retailing, right? Warehousing, right? So those are the questions we can ask to measure the supply chain practices, right? So can we remove one question? We can't. So let's say we remove questions measuring the logistic practices under the supply chain practices, then it will not completely measure the supply chain practices variable, right? So that means we cannot interchangeably use the questions. So if so, we call that kind of a measurement scale as a formative measurement scale, right? Formative measurement scale. Because the questions form the variable, right? The different questions form the variable, right? And if the questions reflect the variable, right? And also if we can interchangeably use the questions, we can call such measurement scale as a reflective measurement scale, right? So when we are measuring the measurement scale or assessing the measurement scale in a structural equation model, first we need to identify the type of the measurement scale, right? Whether it's a reflective or formative. So if it is a reflective, we show the questions of a variable in this way, right? So the arrows should be directed from the variable to the question, right? So if this x1, x2, x3 are questions. And, okay, I will explain it again. And if it is a formative measurement scale, the arrows should be used from questions, or arrows should be directed from the questions to the variables, right? So as you can see in here. Okay, let me repeat again. How to identify your measurement model is a reflective or a formative, right? So if it is a reflective, the questions are interchangeable, right? So look at this example. Okay, let me show this example, right? So let's say the variable is a dependent variable, right? So you are going to measure the satisfaction, right? So satisfaction, customer satisfaction, right? So if the questions looks like this, so it looks like, I appreciate this hotel. I am looking forward to staying in the hotel. I recommend this hotel to others, right? So in these questions, can we remove one question and measure the satisfaction? Yes. We still can measure the satisfaction even we remove this variable, right? Because these two still measuring the satisfaction, right? So if so, that means we can interchangeably use the questions, and even we remove one question, there will be no effect on the measurement scale. We can completely measure the variable. If so, we call it a reflective measurement model, right? And then we can, when we are drawing the model, I will draw and show it to you. We are using the arrows from, we are directing the arrows from the variable to the questions, right? So that is how we draw the reflective measurement model. Look at this formative measurement model questions. The service is good. The personnel is friendly. The rooms are clean, right? So look at these. These are measuring different aspects, right, of the different aspects that customers will be satisfied, right? So can we interchangeably use these questions? No, these are measuring different aspects, right? So these in order to in order to measure the satisfaction, all these questions should be there. If we remove one question, these questions doesn't completely measure the satisfaction, right? So if the questions looks like that, then we call such a measurement model as formative measurement model, right? So this is how we are drawing a measurement model from questions to the variable. Is it clear now? So researchers decide if scale is reflective, formative, or some analysis need to be performed. Actually, there are ways to find whether your measurement model is a reflective or formative. You can look at your base paper, right? So that means there are papers you got these questions from, no, right? So in there, if they have, see whether they have mentioned whether their measurement models are reflective or formative. That's a one way, right? And if not, you can look at how the measurement model is tested. So I will explain you what are the ways that we are going to test the measurement models for reflective and formative. If you look, I mean, using those tests also, we can identify whether you have a reflective or a formative model, right? If not, here, there are different criteria to look at to decide whether your model is a reflective or formative. So if you have wrongly identified your model, there will be a complete disaster, right? Because if you are going to test a reflective model as a formative model, the test will not come properly, right? The results will not come properly, right? So that's why you need to identify your model whether reflective or formative, right? So this is a very important part. So these are the criteria. So you can see whether the causal priority between the indicators and the construct. The construct means the questions, right? So if the causal priority is coming from the construct to the indicators, so that means from the indicator to the variable, right? That's a causal priority, right? If so, this is a formative. Sorry. Construct is the variable, indicators are the questions, okay? I'm sorry. So if the causal priority coming from the indicators to the construct, then this is formative, right? And if it is from construct to the indicators like this, it is reflective, right? And also, you can see if the construct a trait explaining the indicators or rather a combination of indicators, right? So if the indicators or the questions, so keep in your mind, indicators means questions. Yes, indicators means questions. Construct means the variable, okay? So if the indicators are traits of the construct, right? So that means the traits are, so in that satisfaction question, so all the questions are like something like what the satisfied customers do, right? If I go to the example again, all these questions or indicators are what a satisfied customers do, right? So it's kind of a trade, right? If I'm satisfied, I will appreciate the hotel. If I'm satisfied, I will come back to the hotel. If I'm satisfied, I will be recommending the hotel, right? So it's a trait of the construct. If so, it's reflective. But if the indicators form, these indicators are forming the construct, right? That means the indicators, these three indicators should be there to form that satisfaction. The service should be there to be satisfied. The personnel should be friendly to satisfy. The room should be clean to satisfy, right? So it's kind of a form in the construct, right? The indicators are forming the construct. So that means that measurement model is a formative. And also, do the indicators represent consequences or cause of the construct? So if the indicators are consequences, it's reflective. As I told you, a satisfied customer is a customer will be coming back and recommending, right? So those are the consequences of the satisfaction. So then it's a reflective. And if the indicators are causes of the satisfaction, right? Then that's a formative. And it is necessarily true that if the assessment of that trade changes, all items will change in a similar manner, assuming they are equally coded, right? So if one trade it changes and all the trades are changes, then that's a reflective. If one trade is changes, all others are not changes, that's formative, right? So that means here, if we are not appreciating this hotel, we are not going to coming back again, right? And we are not going to recommend again, right? So all are, if one changes, all others are should change, right? But there can be instances the service is not good, but the personnel are friendly and the rooms are clean, right? So the change of one will not change the others. So that's why this is a formative. And finally, are the items mutually interchangeable? So if we can mutually interchange the items or the indicators, then that's reflective. If we can interchange, if the items or if the indicators are interchangeable, if the items are not interchangeable, that's formative, right? So as I told you, you can look at the base paper or you can analyze your measurement models using these criteria, right? And then you can say your measurement models are reflective or formative. So I got multiple questions. Indicators means questions, but more factor will not strengthen the question. Yeah, yes, of course, right? Yes, this is not about the number of questions, okay? So here I have drawn an example. This is an example, okay? For you to understand a measurement model or understand a reflective measurement model or a formative measurement model. This doesn't mean, so I haven't said I'm going to remove one question in here. The idea is even if we remove a one, there will be no impact, right? So there will be no much of a change in the other questions, right? So that's the idea, okay? I doesn't indicate or meant that we are going to remove the questions, okay? What you are saying is true. The more the questions, the better the model is, okay? So I think you got it. So researchers, okay, I have, yes, I have replied all the questions, right? Yes, please ask the questions, okay? If you're not clear what I am explaining, please ask the questions, right? So now I think you understand what is meant by a measurement model, okay? So let me go to the software and show it to you. So this is the software we are using for PLS-SEM, okay? The software is called Smart PLS. This is a version 4, right? So you can get this software from the Smart PLS website. There are different versions. Okay. Let me show you. Ma'am, you have told. You have told to follow 2-step for same. And can you again mention it again, please? So the 2 steps in SEM analysis is, the first one is the measurement model analysis, or you can call it assessing the measurement model or measurement model assessment. The second stage is the structural model assessment or assessing the structural model, right? So that means you have 2 models. measurement model and structural model, right? So those are the two main stages of the SEM. So let me show you the software. Okay, so the software you can use under the student license for free for whatever the time you wish, but there are limitations, right? So that's what I'm going to use in here to show you the students version. So there you can only analyze 100 data. Okay, so that is the, and also there will be a few of the analysis will be deactivated. Okay, or you can go for professional license. It's a paid version, right? So certain institutions have or provide their students this professional license, which is full-fledged. All the analysis is there, and you can analyze as much as data you want, right? 1,200, likewise. Or you can go for at the beginning. You can use the free 30 days trial, which is a professional one, right? So you get to access to the professional version for 30 days as a free trial, right? So you can use this as well. So, and also this can be, let's say that you are going to get this three days trial, right? So you cannot again go for 3 days trials because they are tracking your email and your IP, right? So for the same computer, you will not be able to install this 3 days trial again. Okay, keep that in mind. So you need to have a new email address and a new computer. So I haven't purchased it for this course because it will take a bit of a time a day to purchase it. And also we need to pay it. Paid version is a very expensive, right? Keep that in mind also. And you cannot find a track or crack, sorry, not a track, a crack of this software as you can find cracks of other softwares. Okay, keep that in mind. But this is a very easy software to use, a very user-friendly software, right? So you can download very easily to a Mac or a any other computer, Windows or Mac, it doesn't matter. It works for any computer. So you can provide your mail address. Right, so likewise you can get the access. This is the student version because as I told you, I have used my 30 days trial, and also I have not paid for professional version. But you can do your basic analysis using this, right? So you will get the access. So here is my interface, right? So let me show you how to do the measurement model analysis and how to draw it first, right? So here you can see different features. First, you will need to define your workplace. So you can click on this and you can select a folder that you can create. So I have my flow folder in here, right? So you can create a folder and open it. Since I have already defined my workplace, I'm not going to do that. So look at this, right? So the type of analysis now we can do in PLS-SEM, Smart PLS So earlier, we could only do the PLS-SEM in smart PLS, right? But now you can do the factor analysis, right? And also even CB-SEM. Now you don't need to go for AMOS and use the smart PLS to do the CB-SEM. And also you can do the confirmatory factor analysis because it's a basic part in CB-SEM. And you can do the PLS-SEM, or you can do just regression analysis, right? So here the software provides free examples, right? Which you can work on or practice on the software, right? And also, let me show you. And also, this is the book they are using to explain the most of the part, right? This book, you can get the PDF from the Google. If you search this book with PDF at the end, you can find this book, right? So they have given examples in the book, and also the examples have been given, drawn, and the data also given in the software itself, right? Okay, so let me show you how the software can be used to measure a measurement model. So let me show you this. Okay. So when you are using the software, first you need to start or open up a project, right? So you can click on this one and you can give the project name. Let's say that you are doing your MBA or PhD analysis using smart PLS. You can call the project as PhD, right? And create. So this is my new. These are the old analysis I have done and also used in teaching. So this is the new project, right? So there I can first import my data file, right? So here you can click on this and you can click on your data set, right? Which is in Excel. But here you need to be, see, if you are using the student version, it should be in CSV format, right? And then you can click on the data file and you can get that data file, right? So here, this is, sorry, this is such a data file. Okay, not this one. So you will get your data file uploaded like this, right? So since I cannot upload the large data files because this is a student version, it's only allowing you to use 99 or 100 data, right? And then you can create a model, right? Then you can click on this and you can give the model name. Let's say this is a measurement model, and also you need to select the PLS-SEM, and you can give the model name with the variable in the model, right? So let's say you have a variable called TT and MT and CS, right? So you can give the model name like this, and also you can call it as measurement model. Okay, then you can save. So this is the interface that we can use to draw the models, right? So here, let me choose the data file. Okay, here I haven't uploaded a data file, so I'm going back and let me show a one with the data file. Okay, so here, let me show you how to create a new model. So I'm going to create a new PLS model. So let me call it PLS-SEM new measurement model. Okay, so I'm going to select the data file. This is the data file, right? So look at this. This is a very important, very easy task, right? So now I am going to draw my measurement model, right? So let's say I have the variables called COMP. So what I am doing in here is go this side, this pane of the interface, and I am going to select the 3 variables I am going to use to measure the variable called COMP. 3 questions I am going to use to measure the variable called COMP, right? So what I simply did was drag and drop, right? Which is a very easy one. Let's say that I want to bring these questions or indicators to this side. So I am going to click on this one and click on here. So I'm having all the indicators in this side, right? Let's say I'm having another variable called like. What I did was simply drag and drop, right? And here, and my dependent is, let's say, called CUSL. Okay. So I have 2 independents. I have a 1 dependent, right? And here you can see all these nodes are in red. It's because the model is not complete. I'm going to go this and click on this connect, and I'm going to connect these variables, right? So all became blue, right? So that means the model is complete, right? So if there are any variable is not connected, that will be shown in red, right? So this is my model, and this is my measurement model also, right? So here the structural model and measurement model is the same because I have only 2 variables, right? And let's say I have another mediator. Okay, this is my mediator. This is a very easy software to use. This is my mediator, right? And let's say this mediator mediates the relationship between COMP and CUSL, right? So this is my actual structural model, right? This is my model looks like. But if you are measuring your measurement model, you need to connect all the variables like this, all the independence to all the mediators and to the dependent, right? So this is connected to this is connected to this is connected to this, and this is connected to this, and this is connected to this, right? So I'm not to connect these 2 because these 2 are independent, right? And let's say you have another mediator. Right? And let's say it mediates the relationship between like and CUSL. So this is how we draw the mediator. This is how we draw the mediator, right? But if it is your measurement model that you are testing, you need to connect all like this, right? And you are not connecting the 2 mediators, okay? The same nature variables are not connected with each other, but will be connected with all other types of variable, right? Okay, so this is my measurement model, right? So I am going to test my measurement model. So what you need to, so what kind of a measurement models are these? Are those reflective or are those formative? What do you think? Now you know the nature of the reflective and formative measurement models, and you know how to draw the reflective and formatives. Tell me, are these variables or constructs are reflective or formative? Yes, very good, reflective, right? Because you can see all the arrows are directed to the indicators, right? But let's say this is a formative one. This CSOR is a formative measurement model or formative variable, right? So what you can do is you need to direct these arrows from the indicators to the construct, right? You can do that as well. So you can click on this, and you can select this invert measurement model. Look at this. Look at this. Very easily, you can draw reflective and formative measurement models, right? So I am going to now test my measurement model, right? So if your measurement model is having all reflectives like this, so you have all the reflectives, right? So what you are going to do is go calculate and click on this PLS-SEM algorithm. Okay, keep all these default selections as it is and go start calculation. This is your output, right? This is your graphical output. This is your other outputs, right? So when we are assessing our measurement scales, if those are reflective, if your measurement models are reflective, so in these slides, everything is explained very clearly to you, okay? I'm not going to read this out to you. All the thresholds are explained. Let me show you a summary of test so you can understand what you need to do. Okay. So in this matrix, disregard these parts, okay? Disregard these parts. Okay. So and also this part. Okay. You need to look at this part, and this part. Okay. Only these two parts. Okay. Right. So if your measurement model is reflective, how you are going to assess your reflective measurement model? So you need to test your internal consistency reliability, right? So how you are going to test it? You need to look at the factor loadings. You need to you need to look at the Cron-Bashas alpha, and you need to look at the composite reliability, right? So you have two, row A and row C, and you need to look at for validity, for convergent validity, you need to look at the indicator reliability, average indicator reliability, and average variance extracted, or in short, we call it as AVE. And for discriminant validity, you can look at cross loadings, Fornalaga criterion, and HTMT, right? So using the output, I will explain those. Okay. So let me go to the output. Okay. So all the measurement models are reflective. Minimum, how many responses are required to conduct confirmatory and exploratory factor analysis for new tool? So that's a different analysis. No, I have done a one measurement scale building research with someone else. So there we haven't found any specific number of data points, right? So if you can get, let's say, you have 10 indicators that you are using in your exploratory factor analysis or confirmatory factor analysis, right? You have 10 indicators, and it's better if you have more and more data, right? Something like 100, 150, 200, right? So, but actually, if you look at the these books and the different scholars' recommendation in the minimum number, there is no specific, right? So it's something like there are different factors, different aspects you need to consider when selecting, when deciding the minimum number of responses. So one is the population and the other is the analytical method, right? So different analytical methods use different recommendations, right? So as I told you, for SCB, SEM, it is 10 times, minimum 10 times, right? But in certain other references I have seen, that is not actually required. 5 times is also doesn't matter, right? Or 100, having 100 is enough, right? So likewise, in different places, it is being mentioned in differently, right? So that because of that, I cannot give you an exact amount. So if you can have 10 times or 15, 20 times to support your analysis, that's better. That's my recommendation. Did you get a proper response? Okay, right? So even for the PLS-SEM, if you look at certain references, they might say the 100 is enough, right? So that should be really carefully used. So let's say that you have, using those references, you have collected only 100. So sometimes your reliability and validity will not be satisfied, right? So that's why you need to be carefully decided the minimum responses. Okay, right. So what we look at is, since all these variables are reflective, we are going to look at indicator loadings. Sorry, not this one. Indicator loadings. Look at this. The indicator loadings, right? So the same thing will be, you can see. Look at this. So the loadings that you see in the graphical output, you can see in here, out loading. So these are the indicator loadings, right? So you need to report this, right? And what we are looking at in here. So look at this. So here we need to have the loadings higher than 0.7, right? So except one, all the others are higher than 0.7, right? So here, since it is 0.6 something, it's somewhat okay, right? But if let's say you have some questions or indicators loaded with 0.2, 0.4, that means that question is not suitable in the model, to use in the model, right? So here you can decide whether to remove that question or not. In here, we don't have a problem, except one, all the others are above 0.7, right? So that means we can use the indicators to measure the variable, okay? And we next look at Cron-Bashes alpha, right? For each variable. And also composite reliability row A and row C. What you get composite reliability is this row C1, and you can report the row A as well. But in your articles, you can only show this one is enough, right? So here also we can look at whether the Cron-Bashes alpha is more than 0.7 or not, right? And also the composite reliability. So these are the reliability measures, okay? So all are above 0.7, that means okay. And also we need to look at the discriminant validity. Sorry, we need to look at the AVE, average variance extracted. Sorry, this one for convergent validity. So this should be above 0.5, right? So that is also okay. And also for discriminant validity, we can look at the cross loadings, this one. So here we are seeing whether, look at this. These are the questions that we are measuring ATTR variables, no? Variable, no, right? So the questions measuring this variable should load higher to that question variable, but not to other variables, right? So here the highest is on ATTR, not on other. Highest in on here, highest in here, right? So for all the variables, we are looking at whether the highest or above 0.7 loadings are only on that variable or not, right? So let's say this ATTR2 has loaded to this one of these other variables above 0.7. So that means this variable is measuring this one and also this one. The question is similar to the ATTR and also other questions in COMP, right? So that means that's a really bad problem in your model, right? That's an issue. So if you have higher cross loadings, you will have a discriminant validity issue, right? So you can look at the cross loadings and Forner-Larker criterion, right? So here you see whether all these diagonal values, these are the diagonal values, right? Are the highest below the values, below values, right? So look at this, all values are higher than the below values, right? And here also, let's say this value is higher than this. That means the questions in COMP and ATT are similar. Okay. I got a question. Right. And then the most, we say the most proper way of measuring the discriminant validity is using HTMT. That means heterotrait monotrate ratio analysis, right? So this is that. If you click on this HTMT matrix, you can see, right? So here the value should be above 0.5. So here we have issues. Between these two, we have 0.9, a very high value. Between these two, we have 0.9 again, a very high value. Between these two also, a very high value, right? So that means there is discriminant validity issue, right? So if you have such problems, you need to go back to your cross loadings and figure it out. Okay, so it is 8:30 again, right? Yes. If you want to leave, you can leave. So this is the measurement. Sorry, this is how we measure the measurement model if it is a reflective one, right? So let's say it is formative. You can save this output. I cannot do it because this is student license, right? This is my model now, right? So I have drawn it as a reflective model. Let's say all these are formative models. All these constructs are formatives. Okay, right. So then how we are going to measure the measurement model of a formative constructs. So let me show you the types of tests that we are going to use. So if the measurement model is a formative, what we look at is the convergent validity and collinearity between indicators and significance and the relevance of the outer weights. Outer weights, yes, significance and the relevance of the outer weights, and also we can look at the outer loadings as well. So these are the ones we are looking at, right? So let me show you those results. So now we are going to, we need to do the test again or analysis again, because now our model is a formative one, right? Right. So we need to look at the not convergent validity. It's, we need to look at the, yes, convergent validity. Right. conversion validity, right? So here we cannot test the conversion validity if we don't have a global measure, right? So what is a global measure, right? So global measure means, let's say to measure this one, we can, if we, let's say this is the satisfaction, then we can use a one question to measure the satisfaction, right? So that is called a global measure. And what we do in measuring conversion validity is, we are going to run, let me save this and go back and let's say we have okay, look at this. So we have a variable called ATTR, right? And we are using 3 questions to measure it, indicators. And we can have a one variable, a complete one variable as a global measure to measure the same thing, right? So you need to find it from questioning, from articles, right? So here what we do is, we are drawing this separately again. That means we are going to draw this variable in a separate model, and also the global measure, right? And we are going to run the test and see whether R square is high or not, right? So that we cannot do. I'm not going to explain that, because most of the time you cannot find a global measure, right? If you can find it, you can do the convergent validity analysis. And then if you cannot use the convergent validity analysis, you can go for other analysis, which is collinearity between indicators. This one, VIF, right? So we look at whether VIFs are lesser than lesser than 1.5, lesser than 1 or lesser than 3, right? So if it is lesser than 1, it is good. It is way better. But even if it is lesser than 3, that's what we want, right? So look at this. 1 is higher. That means there is a collinearity issue. That means multi-collinearity issue, right? And also we look at the outer loadings and outer weights. First, we look at the outer loadings, and if you find anything in red, you can go and do outer weights. Sorry, this is outer weights. This is the outer weights values, right? And also we can find the significance of the outer weights. So keep this in mind. If we are to find significance of anything when we are using PLS-SEM, right? What we need to do is, we need to run a bootstrapping, right? When we are testing hypothesis, right? Or when we want to test the significance of any test, when we are doing PLS-SEM we need to run a bootstrapping, right? And you can go to outer weights, and this is the significance of the outer weights, right? Here we have few problems in the significance. What we want is the p-values to be lesser than 0.00, right? Or 0 this should be lesser than 0.05, right? So here have higher p-values, so p-values. So that means the outer weights are not significant, right? So that means our formative model have issues, right? So one reason I got issues in here is, this is actually a reflective model, right? The most of the questions are reflective, right? Or this question can be reflective. Not this question. CSOR. This variable can be reflective, right? So if you measure the reflective model as a formative, you will get issues in reliability and validity, right? So that's how we are testing or assessing our measurement model, which is the first phase in PLS-SEM, right? And after your reliability and validities are assessed and ensured, then you can go to your structural model analysis, right? So let me explain this to you in very briefly. right? So this is a measurement model now, right? So let me make a copy of this. You can copy, duplicate, and this is my structural model, right? I haven't made the structural model yet, but I am going to do it in this model, right? So I'm going to change this one to a structural model, right? So what you need to do is you need to draw it as in your conceptual framework. So let's say this is your conceptual framework. This is how your conceptual framework looks like, right? These are the two independents, and these mediators mediate each of the relationship, right? And you are drawing the these arrows only as in your conceptual framework, no more arrows when you are testing your structural model, right? So I'm going to do structural model assessment, right? So here what we are looking at mainly is this. Sorry. Mainly we are looking at this R square, right? This is your final variable. This is the R square of the model, which is 42%, which is not a good value, right? And F square. And F square of the each independent, right, should be higher than 0.5, right? And you can look at collinearity statistics, right? Collinearity statistics, this one, right? Here also it should be greater than, sorry, lesser than 1 or lesser than actually 3, right? If it is lesser than 1, that's way better, or lesser than 3 is also okay, right? And after satisfying all these R square, F square, and VIF values, you can go and so in your structural model is the place where you are testing hypothesis. Okay, that means you need to do the bootstrapping, because in hypothesis you have p values, right? So here when you are doing bootstrapping, you can change it to 10,000, right? Higher the better. And this one to complete slower, right? And you can start the calculation. Okay, so what we are looking at mainly is this, right? So the impact of this on this on this, whether those are significant or not. Here it is not significant, here it is not significant, here it is not significant, right? So this is how we test the direct impacts, right? Let's say you have mediators as in my model, right? Then you need to go to these specific indirect effects. So here it shows whether your mediators are significant or not, right? So here my two mediators are not actually mediating, right? So that is how we are doing the main analysis in the PLS-SEM. So actually, we need few sessions to complete PLS-SEM, because it has certain complex, to discuss how to test the complex models. But I think you can get a basic idea to use how to use a PLS-SEM, and also you can use a lot of resources are out there. One resource that I am recommending is a YouTube channel called Research with Fawad. So he has a website dedicated to data analysis, and also his YouTube channel have full explanation of using CBS-SEM, PLS-SEM, right? Lot of data analytical parts in a research, and also go to PLS-SEM website. So there you can find many resources to learn about. Okay, the channel name is Research with Fawad. So that is one of the channels. The scholars who develop this software are recommending. Here, Stardust and Ringles are recommending the research with Fawad, and there is another YouTube channel that you can find everything in PLS-SEM website, right? Examples and resources and books and everything, right? So that's all I can cover up in this time. And I hope you get some kind of an idea about PLS-SEM. Can we calculate? Yes. Can we calculate moderate effect using PLS, or do we need any plugin? Yes, we can do all the moderators, right? Moderators, mediators, and mediators together in the PLS-SEM. I haven't shown it. Okay, I will very quickly show it to you. If there is a moderator in your, sorry, if there is a moderator in your model, let's say, I'm doing it very, very quickly because the time is already up. Let's say this is your moderator, okay? This is your moderator, right? So let's say the moderator is moderating the relationship between these two. Then you are drawing it like this, right? Sorry, like this, right? So this is how you model your moderators in your conceptual framework also, right? So this is how you model a moderator, but when you are looking at the results, it is a bit different. But you can all find everything, moderating, mediating, higher orders, which is I have not discussed today. You can find all the resources online, as I told you, with the platforms that you can easily refer to. Okay, so I hope again you have got some kind of an idea in SEM and PLS-SEM, which you can use in your analysis, quantitative analysis instead of using just regression analysis. Okay, so thank you so much. Have a good rest of the day.
Okay. So as we come to the end of today's session, I would like to take a moment to express our sincere gratitude. First, heartfelt thanks goes to a insightful and informative session. Your clear explanation of data analysis techniques have undoubtedly enhanced our understanding and will be immensely valuable in our research journeys. We truly appreciate the time, effort, and expertise you have shared with us today. I would also like to extend my appreciation to all participants for your active engagement and interest throughout the session. Your enthusiasm and commitment to learning are what make program like this meaningful and successful. We hope to see you all in the upcoming sessions of this lecture series. So thank you again and have a wonderful day. Thank you.
Thank you, Diniti, and thank you all for actively participated because I enjoyed a lot. Because you ask questions and hope you can do good research in the future. Have rest of the day.